Hello, and welcome to Summarize Science, where we break down the latest research into bite-sized pieces. Today, we're looking at a fascinating question. What's the difference between a star that's formed in a direct collision versus one formed from a slow merger? Astronomers believe a significant fraction of stars aren't isolated. They interact, and sometimes they combine. One way is a direct collision, a rapid and violent event you might find in a crowded star cluster. Here, you can see a simulation of a 10 solar mass star colliding with a 5 solar mass star. The other way is a merger, where two stars in a close binary system spiral into each other over a much longer period. This visualization shows a similar pair of stars, but this time they are merging as a binary. Researchers used a powerful code called a repo to simulate these events in 3D, including the effects of magnetic fields. So, what did they find? Well, both collisions and mergers produce a single, more massive star that spins rapidly and is highly magnetized. But the devil is in the details. Merger products actually end up with a slightly higher concentration of hydrogen fuel in their cores. This means they are rejuvenated a bit more effectively and can live longer as a result. The differences become even more stark when looking at their structure and magnetic fields. This incredible figure compares the outcomes side by side. The top row shows a near head-on collision, the middle a grazing collision, and the bottom shows a merger. Notice how the density contours of the merger product on the bottom left are distinctly peanut-shaped, while the collision products are just flattened spheres. But the most dramatic difference is revealed here on the right. Only the merger product produces powerful, bipolar jets of material shooting out from its poles. These outflows, traveling at over 300 kilometers per second, are driven by a strong, organized magnetic field. The collision products, especially the head-on ones, create messy, tangled magnetic fields that don't produce these jets. So let's recap the important points shown in this summary table. While both processes create massive, fast-spinning stars, the outcomes are clearly distinguishable. Mergers create peanut-shaped stars with large-scale, ordered magnetic fields. These powerful fields drive magnetized outflows or jets, which are completely absent in collision products. Collisions, particularly those that are more head-on, result in a less extreme product with a messier, weaker magnetic field that may not last long. So, what does this mean for the future? These distinct signatures could allow astronomers to look at an unusual star, like a blue straggler, and determine its violent history. It also provides a clear pathway for forming the long-lived, stable magnetic field seen in some massive stars, which are thought to be the ancestors of ultramagnetic objects called magnetars. It turns out, the products of stellar collisions and mergers really do not look alike. Thanks for watching.